Hi everyone. In this session, we are going to discuss some of the important questions from the chapter Electricity. Here we are going to discuss the textbook exercise. Important questions and answers set 4. Let's start the discussion. When a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of the resistance of the resistor. First, we need to write the given values. The given values, the voltage. The voltage is given, V is equal to 12 volt. Then second is current 2.5 milliampere, I is given 2.5 milliampere. We need to convert this milliampere into ampere. How we can convert this one? To convert milliampere to ampere, we need to divide it by 1000 or into 10 raised to minus 3. Then the current I will be 2.5 into 10 raised to minus 3 ampere. Here what we need to find? We need to find the resistance. According to Ohm's law, the equation is R equal to V by I. Then it will be R equal to 12 by 2.5 into 10 raised to minus 3. 12 by 2.5, it is 4.8. That 10 raised to minus 3, we are taking it up to the numerator, it will be 10 cube ohm. Then the resistance is 4.8 into 10 raised to 3 ohm. A battery of 9 volt is connected in series with the resistors of 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm respectively. How much current would flow through the 12 ohm resistor? It is a series connection. In series connection, the current is same for every resistor. That is important point here. In series connection, there is no splitting of current. Current will be same for all the resistors. So we are going to find the effective resistance. It is in series. Then how we can find the effective resistance? R equal to R1 plus R2 plus R3 plus R4 plus R5. We are substituting all the values. It will be 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. It is 13.4 ohm. That is the effective resistance of this circuit. Now we need to find the current. For that they given the value of voltage. The voltage V is equal to 9 volt. The current I will be equal to V by R. Just substitution. I is equal to 9 by 13.4. It will be 0.67 ampere. Since it is a series connection, the current through 12 ohm resistor will be 0.67 ampere. The current will be same for all the resistors. How many 176 ohm resistors in parallel are required to carry 5 ampere on a 220 volt line? This question is very simple. The resistance of one resistor is given. It is 176 ohm. We need to find the number of resistors which is required to carry a current of 5 ampere. The voltage is 220 volt. The current is given, voltage is given, the value of one resistor, it is also given in the question. We need to find number of resistors to get 5 ampere current when the voltage is 220 volt. So we are assuming the number of resistors, it is X. Number of resistors equal to X. When we are connecting this in parallel, what will be the equation? When we are connecting these resistors in parallel, the equation will be 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 etc. It will be like that, right? Here the resistance is 176 ohm. It will be 1 by R equal to 1 by 176 plus 1 by 176 plus 1 by 176 etc. X times, because the total number of resistors, it is X. It will be resistance of one resistor is 176 ohm. Just imagine it is having two resistors. What will be the effective resistance? 1 by R equal to 1 by 176 plus 1 by 176, two resistors. If it is three resistors, if there are three resistors, the effective resistance will be 1 by R equal to 1 by 176 plus 1 by 176 plus 1 by 176, 3 times. If it is having X resistors, it will be 1 by 176 into X times, right? So effective resistance 1 by R equal to X into 1 by 176. If there are 2 resistors, 2 into 1 by 176. If there are 3 resistors, 3 into 1 by 176. Here it is X resistors. It will be 1 by R equal to X into 1 by 176. That is the effective resistance. 1 by R is equal to X by 176. Then R will be equal to 176 by X. Now we need to find the value of X. We are going to find it. The value of V is equal to 220 volt and value of I equal to 5 ampere. We are substituting the values here. It will be 5 equal to, instead of V we can use 220, right? Instead of V we can use 220 divided by, instead of R we can use 176 by X. It will be 176 by X. We need to take the multiplicative inverse, reciprocal of this 176 by x, it will be 5 equal to 220 into x by 176. Reciprocal of 176 by x is x by 176. From this equation can we find the value of x? Yes, we can find the value of x. We are going to find that value. X equal to 5 into 176 by 220, which is equal to 4. There are 4 resistors, then we will get 5 ampere of current. If the resistance is 176 ohm, if we are taking 4 resistors of resistance 176 ohm and we are applying 220 volt of potential, then the current flowing through that circuit will be 5 ampere. 4 resistors are required. Next question. Show how you would connect 3 resistors, each of resistance 6 ohm, so that combination has a resistance of 9 ohm and 4 ohm. There are 3 resistors. Each resistors are having the value of 6 ohm. So there are 3 6 ohm resistors. We need to connect it, and effective resistance should be 9 ohm, that is first question. Second question, 4 ohm. Just imagine we are connecting it in parallel. It will be 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. It will be 1 by 6 plus 1 by 6 plus 1 by 6. It will be 3 by 6 and R will be 2 ohm. 6 by 3. It will be 2 ohm. But in the question it is 9 ohm and 4 ohm. So this method is not possible. Let's try with series connection. R equal to R1 plus R2 plus R3. It will be 6 plus 6 plus 6. It is equal to 18 ohm. In the question it is 9 ohm and 4 ohm. So these two methods are not possible. We need to mix parallel and series connection. Let's try that. Now we are connecting 2 resistors in parallel, 1 resistor in series. These 2 resistors are in parallel, and this resistance is in series with this parallel connection. 6 ohm, 6 ohm, and this is also 6 ohm. How we can find the effective resistance of these 2 resistors? First we are considering this parallel connection. The equation is 1 by R equal to 1 by R1 plus 1 by R2. It will be 1 by 6 plus 1 by 6. 1 by R is equal to 2 by 6. Then R will be equal to 6 by 2. 3 ohm, right? 1 by R is equal to 2 by 6. Then R will be equal to 6 by 2. That is 3 ohm. Now this 3 ohm resistor, here the parallel connection. This parallel connection is having the total resistance of 3 ohm. This parallel connection is having a total resistance of 3 ohm. This 3 ohm resistance is in series with this 6 ohm resistance. This 3 ohm resistance is in series with 6 ohm resistance. Then what will be the total resistance? R equal to R1 plus R2, which is equal to 3 plus 6, R equal to 9 ohm. That is the first question. When we are connecting 2 resistors parallel to each other, third resistor series with this parallel connection, then we will get 9 ohm resistance. Next one, second question, 4 ohm. How we can make a 4 ohm resistance using these 3 resistors? In this connection, 2 resistors are in series and 1 resistor is in parallel, just opposite of the previous one. 6 ohm, 6 ohm and 6 ohm. First we are solving this series connection. If it is in series, if the resistors are in series, what will be the equation? R equal to R1 plus R2. R1 is 6 and R2 is also 6. So 6 plus 6 equal to 12 ohm. These 2 resistors are giving a resistance of 12 ohm, and this 12 ohm is parallel to this 6 ohm. Then what will be the equation? If it is parallel, the equation is 1 by R equal to 1 by 12 plus 1 by 6, which is equal to 1 by R is equal to 1 plus 2 by 12. Denominator is 12. Then it will be 1 by R equal to 3 by 12. 1 plus 2 is 3. R by 1 is equal to 12 by 3. We are taking the reciprocal. It is 4 ohm. Now we got the second resistance also, 4 ohm. If we are connecting 2 resistors are in series and 1 resistor parallel to this series connection, then we will get 4 ohm resistance. Several electric bulbs designed to be used on a 220 volt supply line are rated 10 watt. How many lamps can be connected in parallel with each other across the 2 wires of 220 volt line if the maximum allowable current is 5 ampere? This question is also the similar one. We need to find the number of resistors. Here we need to find number of bulb. But there we don't know the value of resistance. First we need to find the value of resistance. First we are writing the given values. V is equal to 220 volt and P is equal to 10 watt. We need to find the resistance of the bulb. So we are going to find resistance from here. PVR. Which equation we can use? PVR. There is an equation which is connecting these values. PVR. The equation is P is equal to V square by R. From that we can write R equal to V square by P. R will be equal to 220 into 220 all divided by 10. We can cancel the zeros. It will be 220 into 22 is equal to 4840 ohm. That is the resistance of one bulb. Here the question is, we are applying the voltage of 220 volt and the maximum current should be 5 ampere. That is allowable current. How many resistors, how many bulb we need? And we know that it is in parallel connection because it is in the question is clearly mentioned it is parallel connection. If it is parallel connection and value of one resistance is 4840 ohm. Here the value of I is also given, I is equal to 5 ampere. Now we are going to find effective resistance. How we can find effective resistance? Here it is parallel connection. If it is parallel connection, the voltage will be same everywhere. We are going to find effective resistance using Ohm's law. Effective resistance R dash equal to V by I. What is the value of V? V is equal to 220 volt and value of I is 5 ampere. Effective resistance R dash equal to 220 by 5 is equal to R dash equal to 44 ohm. That is the effective resistance. It is parallel connection. We are going to find the value of resistors using the equation 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. We don't know the number of resistors. How many resistors we have, that we don't know. Then it will be 1 by R dash equal to 1 by R plus 1 by R plus 1 by R plus etc. Because we don't know the number of resistors. Why are we using R? We are not using R1, R2, R3 because the resistors are same. The value of resistance, it is same. We can use 1 by R plus 1 by R plus 1 by R plus etc. Here it is 1 by R dash equal to 1 by R plus 1 by R plus 1 by R plus etc. up to n. There are n times. Then it will be 1 by R into n. Right? 1 by R dash is equal to 1 by R into n because 1 by R n times means 1 by R into n, that is equal to n by R. Then it will be 1 by R dash equal to 1 by R dash equal to n by R. What is the value of R? What is the value of this R? It is given 4840. Then we can write 1 by R dash equal to n by 4840. Then we can write R dash equal to 4840 all divided by n. That is R dash. After that we can substitute the value of R dash. R dash is 44 ohm. It will be 44 equal to 4840 all divided by n. N will be equal to 4840 all divided by 44. It will be 110. That is the answer. So we need 110 bulbs to get the current of 5 ampere. A hot plate of an electric oven connected to a 220 volt line has two resistance coil A and B, each of 12 ohm resistances, which may be used separately, in series or in parallel. What are the currents in these three cases? There are two conductors A and B. There are two wires A and B, and value of A is, the resistance of A is 24 ohm, resistance of B is 24 ohm, which may be used separately. Sometime we are using it separately, sometime we are using it in series, sometime we are using it in parallel. What are the currents in three cases? We need to find the current. First we can do it for separate connection. First one, separately, connecting separately. The value of voltage, value of voltage is given, V is equal to 220 volt. Value of R is 24 ohm. How we can find the current? I is equal to V by R. We need to find the current. I will be equal to V by R. 220 by 24 is equal to 9.16 ampere. That is the first one. If you are connecting separately, we will get the current of 9.16 ampere. Next one is series connection. We are going to connect these two resistors in series. If we are connecting this in series, what will be the effective resistance? We need to add it, right? R equal to R1 plus R2, 24 plus 24 is equal to 48 ohm. So effective resistance is 48 ohm. The voltage is also given, the voltage is 220 volt. I will be equal to V by R. I equal to 220 by 48, which is equal to 4.5 ampere. That is in series connection. Now what about parallel connection? It is a parallel connection, 24 and 24. We need to find the effective resistance. 1 by R equal to 1 by R1 plus 1 by R2. It will be 1 by R is equal to 1 by 24 plus 1 by 24. 24 is a common denominator. It will be 2 by 24. R equal to 24 by 2. 1 by R is equal to 2 by 24. Then R will be equal to 24 by 2 equal to 12 ohm. That is the effective resistance. How we can find the current? I is equal to V by R. 220 by 12 is equal to 1.83 ampere. So that is the current flowing through this circuit.